So we're going to work on section 2.4 today, and we have 6 objectives. The first one is going to be to find the exact values of the trig functions for general angles. So you'll see this is going to be moving out from the world of triangles, and we're just going to be talking about angles. So the next objective is going to be to use something we call coterminal angles to find the exact value of a trig function. So that will be a big idea, coterminal angles. Then we're going to determine the sign, and this is SIGN, positive or negative. Determine the signs of the trig functions of an angle in a given quadrant. Then the fourth objective is going to be to find the reference angle of a general angle. Then we're going to put that all together and use a reference angle to find the exact value of a trig function. And then the last objective is going to be find the exact values of trig functions of an angle given some information. So these will be like little puzzle problems. So if you can't read my writing, sorry, you can look in the book. So the first objective is find the exact values of the trigonometric functions for general angles. So I guess we need to talk about what general angles are. So in this section, we're going to extend the definitions of the trigonometric functions to include angles that are bigger than 90 degrees, so that their size is greater than 90 degrees. So recall that in the previous sections, we've been talking about acute angles, which are smaller than 90 degrees. So we're going to let the angles get bigger and see what changes with the trig functions. So here's a picture of an angle greater than 90 degrees in standard position. So recall that standard position is one side of the angle on the positive x-axis and then wherever the other side falls. So this point AB is any point on the terminal side, so recall that vocabulary, the terminal side of theta. So then we're going to define R to be the distance from the origin to the point AB, which we know from the distance formula is going to be the square root of a squared plus b squared. And if you're not seeing that, it's the Pythagorean theorem really, because A is this distance and B is this distance. So that's always going to be positive because it's a distance. So then the 6 trigonometric functions of theta are defined as the ratios. The sine of theta is going to be b over r. And you can see that in this quadrant, that's going to be a positive quantity. And the cosecant will be r over b, since that's the reciprocal. So then the cosine of theta is going to be a over r, but that would actually be a negative number from this picture, right? So we're starting to expand our ideas of trigonometric functions that, oh, they could have negative values. And of course, the secant is the reciprocal of cosine, so it's r over a. So then the tangent of theta is sine over cosine, so b over a, so cotangent is a over b. Provided that, this is really, really important, no denominator equals 0. So the r will never be 0, the distance from the center, but you can see that the a or the b could be 0 depending on where the point is. So if a denominator is 0, then that trigonometric function of the angle is undefined. So this is a concept that we carry forward from algebra, that if a denominator is trying to be 0, that function is undefined. So the trigonometric functions of general angles can be undefined. When we were talking about acute angles in a triangle, that wasn't an issue. So that's what's the big difference from section 2.2 when we had triangle, and so we had all these ratios, and C was like the R, but C could never be 0, and A and B could never be 0 because we were in a triangle. So we'll work on these exercises together in class. And I want to go on to talk about the quadrantal angles. Oh yeah, those are, if we start at the positive x-axis and we go to 90 degrees, that's a quadrantal angle. So we'll fill in this chart together. And I wouldn't recommend memorizing these, but understanding why they have the values that they do. So then objective 2 is going to be to use coterminal angles to find the exact value of a trig function. So two angles in standard position are said to be coterminal if they have the same terminal side. So if I have an angle here, so this is theta, but if I have an angle where I measure it going backwards, and I call this angle alpha, theta and alpha are coterminal because they share a terminal side. So if we let k be any integer, think about what an integer is, and we'll talk about that in class, then any angle equal to theta plus 2 pi k will be coterminal with theta if it's measured in degrees. Oh, so that one should be 360 degrees k. Wasn't looking ahead. And theta plus 2 pi k will be coterminal with theta. So if you start with some angle theta, so here's my angle theta, but you go all the way around and then end at theta, that angle is coterminal. Well, all you did was add 2 pi, or add 360 degrees. Well, then if you add 360 degrees again, you get to the same place. So this also means if you go backwards, that you'll end up at a coterminal angle, like we did with this example. So those are shorthands that you need to learn because we're going to have problems in chapter 3 where you'll need to be able to write your answer in that format. So here's a hugely important idea. Values of the trigonometric functions of coterminal angles are equal. So let me say that again because it's so important. Values of the trig functions of coterminal angles are equal. So when we had that picture where we had a theta and an alpha, all the trig function values of theta will equal the trig function values for alpha. So for instance, the cosine of theta will equal the cosine of alpha because they're coterminal angles. So we'll work on these exercises together. And let's move on to objective 3, which is determine the signs of the trigonometric functions of an angle in a given quadrant. So here's the coordinate plane, the xy coordinate plane. And we already know that in the first quadrant, quadrant 1, x and y values are both positive. So all of the trig functions have positive values because you're still with acute angles. So it's like the previous sections. But then in quadrant 2, we see x values are negative. So in quadrant 2, any of the ratios that have the x coordinate in them will be negative. And then when we're in quadrant 3, the x and the y coordinates are both negative. And in quadrant 4, x is positive and y is negative. So in quadrant 1, they're all positive values. In quadrant 2, because the x coordinate is negative, then the sine and cosecant are positive. The cosine and the secant are negative, and the tangent and the cotangent are negative. So then in quadrant 3, we have the sine and the cosecant. So see that the reciprocals always have the same positive or negativeness. Cosine and secant are also negative, but tangent is the ratio of sine to cosine. So now you're dividing a negative by a negative. So those are going to be positive. So then in quadrant 4, you can see that the sine and the cosecant are negative. The cosine and the secant are positive. And then tangent and cotangent, because you're doing the ratio of a negative and a positive, those are going to be negative. So some students use a mnemonic device like this. All students take calculus, and that tells them what's positive in each quadrant. All of the trig functions, sine and its reciprocal are positive in quadrant 2. Tangent and its reciprocal are the only ones positive in quadrant 3. And cosine and its reciprocal are the only ones positive in quadrant 4. So that can be a handy remembering device for you, or you could make up your own, which is crazier, which will be better to remember. So we'll work on this exercise together. And let's go on to objective 4, where we're finding the reference angle. So reference angles makes it so that we can just memorize the trig function values for the angles in the first quadrant. And then we use what we just did previously to figure out whether it's positive or negative. And we always refer to horizontal. So that's a huge idea in trigonometry. Always refer to horizontal. So if we let theta be an angle that lies in a quadrant, so here's theta, an angle that lies in a quadrant, the acute angle formed by the terminal side of theta and the x-axis is called the reference angle for theta. So some people write theta sub ref for theta reference. Some books use different notations like theta hat or theta tilde or theta bar to say this is the reference angle that connects to this theta. So we'll work on these exercises together in class. And then objective 5 is going to be to use a reference angle. And I'm going to start another video because I'm just about out of time, and this is really, really, really important. So I'm going to make a second video for this section, so stay tuned.